Welcome to this video lecture. Myself Atul Kumar, working as an assistant professor in Department of Computer Science, Rajiv Gandhi Memorial, Government College, Jogindanagar. In this video lecture, I will discuss about types of constraint. So the first constraint is key. So key are basically the attribute or set of attribute that uniquely identify an entity within the entity set. The next constraint is single value constraint. So it requires a value that is unique in certain contexts. The next constraint is referential integrity constraint. So they require a value that refer to actually exist in the database. Next constraint we have domain constraint. They specify what set of values an attribute can take. So I will discuss all these constraints in detail one by one. So constraints are basically the part of a schema in the database. So they are basically the part of schema in the database. So the first constraint is keys, and in this video lecture I will discuss in detail all keys in ER model and relational database model. So the key is basically the set of attribute. Key is basically the set of attributes for one entity set, such as no two entities in this set agree on all the attributes of the key. So it is allowed for two entities to agree on some kind of attributes but not all of the key attributes. So a key for an entity set E is a set K of one or more attributes such that a given two entities E1 and E2 in E1 and E2 cannot have identical values for all the attributes in K. So E can have multiple keys. We usually designate one as a primary key and the remaining keys are the alternate key. So there are different kinds of keys available in ER model and relational database model. Like super key we have candidate key, primary key, alternate key, foreign key, composite key and artificial key. So before going in detail, I will discuss the example what I have taken to explain all the keys. Like I have explained candidate key with the help of this example. So the example I have taken, the example or a relation of a student. So it has attributes: university roll number as an attribute, class roll number as a attribute, student name, date of birth, year, branch section, father name, address and telephone number. So I am going to draw this student table. So we have a student table like this, or student relation, and it has attribute. The first attribute is university roll number. The second attribute is class roll number. The third attribute is student name. The fourth attribute is date of birth. We have date of birth. Fifth attribute is year. Then the next we have branch section as a attribute, and next is I'm writing here, next attribute is father name, and next is address. The next attribute is telephone number. So this is a student relation, and it is consist or constituted of university roll number, class roll number, student name, date of birth, year, branch section, and father's name, address, and telephone number as a attribute. So if I put the value of university roll number here is 2001, class class roll number is 101, student name is XYZ, date of birth is 15/1/11/1999, year is 2020, branch section is B, father name is ABC, address is small ABC, telephone number is 99999. So this is the first entry in this student relation, and these university roll number, class roll number, these are called as attributes of this student relation. Like I have discussed in this, a key is a set of attributes for one entity. So a relation must have a set of attributes, and a relation is also called as table in database, and it has a set of attributes. And in this example we have a attribute university roll number, class roll number, as student name, date of birth, year, branch section, father name, address, and telephone number. So these are the attribute, and now I have entered one row, and the row is 2001, 1001, the name of the student is XYZ. So this the entry that I have entered in this relation is called as row of this relation. This is called as the first row, and we define this as a row, and in terms of database this is called as tuple. So a relation may have a tuple, must have a tuple, and it may have infinite number of tuples. You can add infinite number of many tuples or rows in a relation. You can add infinite number of tuples in a relation. Suppose the second entry I will add in this relation is 2002 1002, and suppose the name of the student same XYZ, and suppose the date of birth is also same, year is 2020. There is some evidences, or there are some situation in which the state name of the student and the date of birth is same, but here how we can uniquely identify this row from the first row? So to uniquely identify, we have assigned a different class roll number here. In this case we have assigned a roll number 1002 to this roll number, student name XYZ, and the university roll number here is 2002. Also the father name is different in this case. Suppose the father name is XYZ. Suppose here the father name is XYZ for the second student 2002 having roll number, and the address here is small XYZ. So also the student father's name is different, but there are some scenarios where the student and the date of birth is different. So how can we identify this row is unique from this row, or this row, the second row, is different from the first row. So to uniquely identify this row from the first row, we have to just set different attributes for this row, and these set of attributes that uniquely identify the entity or the tuple in a relation is called as key. So what is a key? Key is the set of the attributes. Like here we have a attributes university roll number and class roll number that uniquely identify each row in the table, and these attributes or the set of attributes is called as key. So so you must you now clear about what is a key. So there are different kinds of keys. So the first key I will discuss is super key. So what is a super key? A super key of the relation schema R refers to the set of attributes K which when taken collectively will uniquely identify each tuple in the relation. So it may have a set of attributes, like in this example we have a set of attributes university roll number, class roll number, student name, all the attributes. So super key is the set of attribute that uniquely or when taken collectively uniquely identify each tuple in the relation. So next point here is very important, that is a superset of the super key is also the super key. So if we take the superset, if we take here the superset of the key, so in the previous example here the superset is all the keys in this relation. So superset here is university roll number, then class roll number, and date of birth, student name, all this is a superset. When we combine these all attributes, and then it becomes a superset, and the superset of a super key will also be a super key. When we combine these attributes, like all the attributes in this example, like we have how many attributes in this example? We have firstly we 1 2 3 4 5 6 7 8 and 9. So the super key for this superset for this example, it has how many attributes? We have 9 attributes. So we have 9 attributes here. So the superset has the 9 attributes, and these, when we combine these 9 attributes, so these 9 attributes also form the super key of the relation. So super key may have some extraneous attributes, like when we combine all the attributes, then there are some extra attributes, and these extra attributes also the part of this super key. So such extraneous attributes which need not be there in the super key can be eliminated from the key. So we have to eliminate these extraneous attributes from the key. For example, like in the previous example, we have university. Suppose we have a key that is university roll number and student name will form the super key. Just for example, suppose university roll number and student roll number is the super key. Then we have in this super key extraneous attribute, that is student name, that is S name. Without this, if we remove this from our super key, then university roll number also remain the super key, as it uniquely identify each row in the student table, as university roll number for each student is different. So there is one extraneous, that is extra attribute in this super key that can be if we remove this extra attribute, then university roll number again is a super key, as it uniquely identify each row in the student relation. So next, what are the different properties of super key? The first property is every relation should have at least one super key. So if we have a relation, then there must be at least one super key be there. The next is a candidate key is the subset of super key. So suppose we have a super key that is made up of 4 attributes, and in this line it is saying a candidate key is a subset of super key. And suppose we have a candidate key of 2 attributes. Suppose we have the attributes of super key like university roll number, first attribute is university roll number. Suppose the second attribute is class roll number, and the third is class date of student date of birth, fourth is address. These are 4 attributes of super key, and in the second point it is saying a candidate key is the subset of super key. So we have to make a candidate key from this super key. So candidate key, suppose, contains 2 attributes. First is university roll number, and the second, suppose we have class roll number. So these attributes are also available or present in this in the set of the attributes of super key. So these the candidate key is the subset of this super key. Next we have a candidate key is the minimal or irreducible super key. So like in this example we have only 2 attributes in candidate key, and these are the minimal, that is we can't again subdivide these attribute to further processing, and they are irreducible, means they can't be broken down into the next level of attributes. Next is a super key can be formed by the combination of any number of attributes in a relation that satisfy the uniqueness property. So it also satisfy that each row in the relation must have uniqueness property that is unique from every other row in the relation. Next key we have a candidate key. So candidate key is defined as the super key whose no proper subset is a super key. That is again this is the definition of actually the super key, and if we if I talk in the simple language, that is a candidate key is the subset of the super key. Like in this example we have 4 attributes and we have taken 2 attributes in the candidate key. So these 2 attributes as a subset of the sets in the super key. So candidate key is a subset of super key, and the another definition is a candidate key is the super key whose no proper set is the super key. That is candidate key is the minimal super key that I have discussed earlier, having no extraneous attributes. A relation scheme may have more than one candidate key. So in a relation you can have more than one candidate key. For example, in the previous relation like student, we have a candidate keys. University roll number can be used as a candidate key, as university roll number for each student is unique. University roll number is unique unique for each student, so it act as a candidate key. Second is class, roll number, year, branch, section. It these three attributes can be taken as a candidate key. So the first candidate key for this relation is a university roll number, the second is class roll number, year and branch section. The next candidate key may be student name, date of birth, father name and address. As if the student name, date of birth and father name is same, the address may be different. So the combination of these four can also be taken as a candidate key. So there are three candidate keys for the relation student. So what is the property of candidate key? So a relation can have more than one candidate key. Like in previous slide, we have three candidate keys. The candidate key cannot contain a null value. So the null, what is a null value? Null value is basically any value. Null value is basically any value, or it may be either 0 or it should be any kind of value that is a unknown or inapplicable. So for example, suppose I have student roll number, and if I take this as a null, so null means it may exist or it may not exist. It may exist or it may not exist. If it may exist, roll number can be any value, like x, y, z, maybe a roll number 0, 0, 1, 0, it may be any kind of value, that is null value. So the candidate key cannot contain a null value. The third property is uniqueness and irreducibility. So it also holds the properties of uniqueness and irreducibility. Uniqueness means if we choose candidate key, that two attributes as a candidate key, then these two attributes can uniquely identify each row in the relation. And irreducibility means the candidate key, if we have taken two attributes as a candidate key, then they can't be broken down further, so that they can uniquely identify each row in the relation. The relation must have at least one candidate key. So there must be one candidate key per relation. There are more than one candidate key, but at least one should be present. Next key that is very important key in a relational database and ER model, that is a primary key. And we in the ER model we use primary key as the name of, suppose the primary key is roll number, so we use roll number, we write roll number and just underline below this roll number, or underline it. So if there is an attribute that is underlined, so that attribute is basically a primary key in ER diagram or ER model. So it refers to one of the candidate key of relation R, which is designated as primary key that uniquely identify tuples in the relation. So as I have discussed earlier, there are more than one candidate key, and one of the candidate key, we take one candidate key as a primary key. One candidate key is taken as a primary key and others are left, they are called as alternate key, and the primary key uniquely identify each tuple in the relation. For example, in the previous relation, that is student university roll number, that uniquely identify each row in the relation is the most appropriate choice of the primary key of relation schema student. So what are the different properties of primary key? The first is a relation can contain only one primary key. So a relation may have more than one candidate key, but a relation has only one primary key. The primary key may be composed of single attribute or multiple attributes. A primary key is a minimal super key. That is, if we have a super key made up of 5 attributes, and if we have only one attribute that uniquely identify each row in the table, so the primary key consists of that only one attribute. So it has a minimal super key. It can't be null. That is also a property of primary key. Next is attributes which are part of primary key are called primary attributes or prime attributes. They are also called as prime attributes. So attributes that form the primary key are called as prime attributes or primary attributes, and the primary key are always chosen from the candidate keys. Also, the cannot contains the null value, as I have discussed earlier, not null. Next key, we have a composite key. So a key that includes more than one attributes. So if a key is made up of only one attribute, that is not a composite key. If the key is made up of more than one attribute, then that key is also called as composite attribute. For example, suppose we have a relation result and it has a composite key, university roll number and subject code, as it is made up of two attributes. One is university roll number and the second is subject code. So every key that is made up of more than one candidate, more than one attribute, so that key is also called as composite key. That key is called as composite keys that contains more than one attribute. Next, what are the different properties of composite key? It can't contain a null value, that is the first property. Also, it is a part of the candidate key. The third is composite key is irreducible, that is we can't broke or divide composite key attributes. So we can't broke or divide composite key attributes. For example, if we have a composite key of student name comma class and date of birth, so it is a composite key as it contains 3 attributes and it is irreducible, means we can't broke this into further student name and class and date of birth to uniquely identify each row in the table. Suppose student name, it can't be uniquely identify each row in the table. Similarly, we have class and date of birth, it is not used to uniquely identify each row in the table, so we can't broke down or divide this composite key further, so it is irreducible in nature. Next important key, it is very important key, that is according to examination point of view, and if we talk about in industry, then this key is also very important. So this key is foreign key. So the as we know, the tuples in the relation are related and the tuples in different relations are related through their common attributes. So in the database we have more than one relation at a time, so more than one relation, and if we want to make a relation between more than one relation, we use this kind of uh, foreign key. So to make a relation between more than one relation, we use a key, and that key is called as foreign key. So there are some common attributes in different relations uh, that are common, and by these common attributes we make a relation between these two tables. Suppose the common attribute here is department ID in the first relation, and then the second we have department ID. So by these two relations that are common, we make a relation. Suppose this relation is student and the second is accounts, suppose, and department ID is common in both relations. So by making the relation with the help of this department ID, we can make a relation, and these common attributes are called as foreign keys in case of relational database system. So the formal definition of foreign key is, it is basically the attribute or the set of attributes which may act as primary key or some other another relation to which it is joined by the relationship. So here in this example we have two relation. One is department relation and other is employee relation. So department relation is basically the primary relation, as it contains a two attributes. One is department number and department name. The first department is physics, thus D2 stands for chemistry, D3 for computer, and D4 for English. And the primary key for this department is department number, as it uniquely identify each row in the department. So the relation that contains a primary key, it is called as parent relation. There is also a relation employee, and in employee we have the relation like employee ID, attributes like employee ID, employee name, salary, and department number. So employee ID in this relation as a primary key, as it uniquely identify each row in the table. Also the primary key is not null in this case, so it is a primary key. Also we have in this relation department number, and to make it just relation between this employee relation and the department number, we have this department number act as a foreign key in this employee relation. So the relation that contains the foreign key is also called as child relation. Like in this example we have first employee E001, the name of the employee is Rahul, the salary is 25,000, and its department number is D1. Similarly we have E002, department number is D2, E003 Deepak 10,000 and D3. If we look in this table to E006, we have employee name Mukesh and salary 15,000, but department here is D5, but this department number is not available in this primary relation D5, so this valid entry is invalid. So this entry is invalid here. So the value in the foreign or the child relation, the foreign key, the values of all the foreign keys must match with the values of this primary key. If it doesn't match, there is also one either it match with the values of, so I'm writing here match with values of primary key foreign keys values, or if doesn't match, then there is also another condition of null. So if we write here uh, instead of d5, if we write here null, then this is a valid entry. Then this is basically the condition of primary and foreign key. Either the value of the foreign key must match with the value of primary key. If it doesn't match, the value in the foreign key must or in the child relation, if the value doesn't match, then the value must be null for the foreign key, or either it is matched, otherwise the entry is invalid in child relation. So if as I have discussed, d5 is a invalid entry as it violates the condition of satisfying a prime foreign key. So there must exist a value in the corresponding primary key relation that matches the primary key the value in the foreign key relation, otherwise other than null values, because the null values are the valid entries for the foreign key values. So what are the different properties of foreign key? So there must be a primary key for the existence of a foreign key. So foreign key relation is a basically a child relation. So the relation that contains a foreign key is called as child relation, and the relation that contains a primary key is called as parent relation. There may exist more than one foreign key in the relation. So in case of relation, there are more than one foreign key also exist. So they are represented in the notations in the italics. So they may contain null values. But if the values are not null, then the values must match with the primary key data. The primary and foreign key can exist in same relation. So there is a case in which the primary and foreign key can exist in the same relation. The foreign key is not necessarily to have the same name as its referenced primary key as long as they have the same domain. Next we have alternate key. So as we know, there are more than one candidate key for a relation, and if we take one key as a primary key, as I have discussed, one key is in the candidate set of candidate key is taken as a primary key, and the other remaining keys are called as alternate key. Suppose in a relation we have 4 candidate key, so one is taken as a primary key and the 3 that are left are called as alternate key. That is the definition of alternate key. So this one is the example. So in this case, employee ID, in this example we have taken employee ID and PAN number are the 2 candidate keys. The first candidate key is employee ID and the second is PAN number. So if we take employee ID as a primary key, so the PAN number must be a alternate key for this relation, that is that contains employee ID, employee name, post, PAN number, salary and department number as the attributes. So what are the different properties? The first property is alternate key is the total number of keys minus the total number of candidate key. That is here total number of candidate keys minus primary key. Alternate key is equal to total number of candidate keys minus primary key. So they may exist or may not exist, as there are the cases where there is only one candidate key exists. If there is only one candidate key for a relation, then in that case we take that candidate key as a primary key, and there is nothing left in the set of in the set of candidate keys to make them alternate keys. So they may exist or may not exist. Also they hold the property of uniqueness. Next key, we have a artificial key, and the key is created using a arbitrarily assigned data. So it is also known as surrogate key, and it is created when the primary key is very complex and large to create. It is also created when no attribute can act as a primary key. For example, suppose we have a relation like this. It has attributes employee name, salary, and post. So no key can be act as a primary key. So in this case you can create another attribute, that is a row ID, and we have 1 2 3 4 5 as the values for this row ID that uniquely identify each row in the column. So this row ID can act as a artificial or surrogate key for this relation. So thanks for watching this video lecture.